Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
In this video, I will explain how to use the gamma function. Let's start by understanding its fundamental definition. The gamma function, often denoted by the Greek capital letter gamma, is a mathematical function that extends the concept of the factorial to complex and real numbers. It's a powerful tool in various fields, especially in advanced calculus and statistics, providing a continuous interpolation of the factorial function. Understanding the relationship between the gamma function and the factorial is key. For any positive integer n, the gamma function of n is simply the factorial of n minus 1. This means that gamma of 1 equals 1, and gamma of 2 also equals 1. The recursive property, gamma of z plus 1 equals z times gamma of z, is incredibly useful for calculations and proofs. Beyond integers, the gamma function offers fascinating values. For instance, gamma of 0.5 is equal to the square root of pi, which is approximately 1.772. This function is indispensable in many areas, including probability distributions like the normal distribution, and it forms the basis for other special functions, such as the beta function. It also aids in solving complex differential equations. When practically using the gamma function, especially with non-integer or complex inputs, it's best to leverage computational tools. Scientific calculators and mathematical software packages often have built-in gamma function capabilities. Programming languages like Python and R also offer functions to compute gamma values. Always remember its domain. It's defined for all complex numbers except non-positive integers, ensuring you get valid results.
Thanks for watching. Consider subscribing if I helped unscramble your problems.